Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
This is about momentum in two dimensions. You're familiar with the one in one dimension where an object collides with another object and they move in a particular way. Sometimes they move together, and then you apply the principle of momentum. What's the principle of conservation of linear momentum?
Total momentum before collision equal to total momentum after collision.
Beautiful. Total momentum before collision equal total momentum after collision. So in one dimension, we are not interested in the components because it's in one dimension, but this one is in two dimensions. So this is about momentum in two dimensions. In two dimensions. So what it means is you will need to consider the components. For instance, this first mass m collides with another mass 2m. Of course, this second mass 2m is stationary. That's why its speed is 0 meter per second. This first mass is moving at a speed of 5 meter per second, collides with this second mass 2m, and they move in these directions. They move in these directions. Of course, that means there will be two dimensions, some x, some y, some x, some y. Okay, we are still going to apply the same principle you talked about, total momentum before collision equal to total momentum after collision. So you need to observe the dimensions. Okay, so let me write it down. Principle of conservation of momentum. Of linear momentum. Principle of conservation of linear momentum is total momentum before collision equal to total momentum after collision. Total momentum before, it could be before collision or separation, because the two objects can be together and then they separate. So total momentum before collision or separation, as the case may be, is equal to total momentum after collision or separation. Or separation, as the case may be. All right, so let's apply it here. What's the total momentum before collision?
Yeah, no.
Are you sure? What's the total momentum before collision? You know, what's the total momentum? You know, momentum is mass and velocity.
Oh.
This is before they collided. After they collided, they move this way. From here to here is before, then after. So what's the total momentum before the collision? Momentum of this one plus momentum of this one, isn't it?
That's 5m plus 0.
Exactly, 5m, because momentum of this one will be m times 5. While momentum of this one is 2m times 0. Okay, so let's write total momentum before collision, total momentum before. Can I just write before? Total before is equal to 5 times 0. But then, because two dimensions are involved now, we need to work in those dimensions. So total before in the x-axis. Let's work with in the x-axis. Total before on the x-axis.
0. No, wait. Sorry. 5m.
5m, because it's actually on the x-axis. Total before on the x-axis. Are you still with us?
Yes.
Total before on the x-axis is 5m, that's 5m1 or 5m plus 2m times 0. I can just write it for emphasis. Momentum is mass times velocity. So momentum of this one is 5m. Momentum of this one is 2m times 0. In fact, that gives us 5m. Am I right? Okay. So let's see total momentum after collision on the x-axis. So total after collision on the x-axis. Total after on the still on the x-axis. We do same for y-axis because this is now 2 dimensions. So let's go. M moved this way at an angle of 53 degrees. 2m moved this way at an angle of theta. We are going to split it into 2, giving a component to x, another component to y, a component to x, another component to y, because it is inclined to the plane of reference. You know what I'm talking about? Okay, so what's the value of this black one? The horizontal component of this one. The velocity is 4. The velocity is 4. So what's the horizontal component of the velocity? What's the value of here? Go ahead. This is what? Pardon? Okay, first of all, we need to even show the directions. It has to move this way, and this one has to move this way, so that they will meet up the resultant, the main vector that we are finding their components. Yes. Okay. We're still using the angle same way. This one, this way, this one, this way. So they move this way and this way so that they will meet up at this point. Okay. So what did you say this value is?
The angle.
No. If this is 4 meter per second.
Okay. 4 side.
This is.
Side.
Is this one supposed to be sine? This is the adjacent to 53. The opposite is the yellow line.
Yeah,
the opposite is the yellow line. The adjacent is this black line.
Okay, so
4 cos 53. This is 4 cos 53. 4 cos 53 degrees. This yellow one is what? This yellow one is what? 4 sine 53. 4 sine 53 degrees. Alright. Let's go. The velocity of 2m after the collision is v2 as given. So what's the vertical component of it? Of the velocity of 2m, which is v2 sine theta. So this is v2 sine theta. v2 sine theta is a normal thing we do in resolution, v2 sine theta. I think I need to clean this so I can write it better. Or even zoom in a bit. What's the horizontal component? We zoom into 100%. So this one is v2 sine, v2 cos theta. All right. So we have all that. Okay. So what's the total momentum after collision on the x-axis? Let's go. What's the total momentum after collision on the x-axis? V2 cos theta and
plus 4 sine 53.
4 cos 53. What you're mentioning are their speed, so momentum is mass times velocity. What's the momentum of this one? Having 2m. That's 2m, the mass times the velocity now, is it not? 2m times v2 cos theta. Are you sure you're listening? So 2m v2 cos theta is the this component, the momentum of this green component. What about this black one, which is also on the x-axis? Go ahead. This black one.
Oh, it is
4 cos 53 is the velocity. Momentum is mass and velocity. What's the mass? M. So m 4 cos 53 or 4m cos 53. So plus 4m cos 53 degrees. Please, I need you to look at what I did. We are looking at total momentum before collision and on a particular axis, x-axis for instance, and total momentum after collision on a particular axis, x-axis for instance. Before collision, the total momentum on the x-axis is just 5m because this one is 0, so we have 5m. After collision, the horizontal component of the velocity, this one is, okay, let me start with this one. This velocity is 4 meters per second. The horizontal component of the velocity is 4 cos 53 because the angle is 53. So the momentum is m times 4 cos 53, mass times velocity. That's why I have 4m cos 53, and it is on the x-axis. For the other one that has a velocity of v2 and a mass of 2m, the horizontal component of that velocity is v2 cos theta. Its mass is 2m. So the momentum is 2m times v2 cos theta. So you have 2m times v2 cos theta plus this. So this is the total momentum after collision on the x-axis, and they must be equal, isn't it? Because total momentum before collision must be equal to total momentum after collision. So let's equate both, and then we'll get an equation 1. Are we ready? Are you still with me?
Yes.
So 5m, which is total momentum before collision, is equal to all this. Hello? So let's go. 5m is equal to 2m v2 cos theta, 2m v2 cos theta plus, I think I need to zoom this in a bit so I can see it better. 5m 2m v2 cos theta plus, let me reduce the font size. 5m is equal to 2m v2 cos theta plus 4m cos 53. All of them have m. M is A, m is A, m is A. So m can cross out, right? M can strike out, strike out, strike out. So what are we left with? 5 is equal to v2. I think we can find v2 from here. No, we can make maybe v2 the set of formula. Make v2 the set of formula. v2 is what? 5 minus 4 cos 53 divided by cos theta. I hope you guys see what I mean. I'm just solving the equation now. Making v2 the set of formula. v2 is equal to 4m cos 53 minus that. v2 is equal to 5 minus 4 cos 53 divided by cos theta. I can call this equation 1. Okay, let's find the total momentum on the vertical axis. Are you ready? Before collision, please sit up. Sit up, please sit up. Sit up, and straighten up. Before collision, what's the total momentum on the vertical axis? On the y-axis? Please sit up. Before collision, what's the total momentum in the vertical axis? There's no movement, there's no motion in the vertical plane now. The only motion you have is in the horizontal plane. So total momentum in the vertical plane or y-axis is 0. It is after collision that you even have a path that is vertical. Before, the entire motion is what? Horizontal. Any motion in the vertical axis? Alright, so no motion in the vertical axis before collision. Okay, so let me write that too. Total before collision in the vertical plane, before in y plane or vertical plane is 0. Do you agree? I've explained there's no motion in the vertical plane before. The entire motion is horizontal. Now let's see total after. Are we ready? That's total after the collision. Total after the collision, we have motion in the vertical plane. What are they? We have the V2 sin theta and 4 sin 53. Am I right? That's the speed together with their momentum. Okay, this one is going up, this one is coming down. So they will all be in opposite directions. You know, momentum is a vector quantity. Direction is important. Are you still with me? Okay, so let me write total after in vertical plane or y-axis. Can I just maintain y-axis? Let's go. Vertical plane is the same thing as y-axis. Y-axis. I could have also said y-axis here. Okay, so give me the total momentum in the vertical plane on the y-axis. Are you ready?
No.
Let's go. What are they? Momentum of this one, which is mass times velocity. That's 2m v2 sin theta. Positive for up, then negative for down, or m times 4 sin 53. Mass times velocity is momentum. 2m times v2 sin theta. Okay, so let me write it. 2m times v2 sin theta. So we have 2m sin v2 v2 sin theta. 2m v2 sin theta. That is for this one. Do you agree? 2m v2 sin theta, and it's positive because it's going up. This other one is negative because it's coming down. It's also a vertical plane or y-axis. What's the mass? What's the mass? What's the mass? M. What's the velocity? 4 sin 53. So what's the momentum? 4m sin 53. And what will be the direction? Negative, because it's going in the opposite direction. So 4m sin 53. So, and it will be minus 4m sin 53. Since total before is equal to total after, are you listening? Total before is equal to total after. Are you listening? So 0 must be equal to 2m v2 sin theta minus 4m sin 53. So equating, we have 0 equals 2m v2 sin theta minus 4m sin 53. So it means, let's make v2 a certain formula here. Again, v2 will be equal to, let's make v2 the certain formula in this equation. v2 will be what? This one crosses over, we have 4m sin 53 over sin theta. 4m sin 53 over 2m sin theta. V2, I made V2 the second formula here. V2 will be equal to 4m sine 53 over 2m sine theta. M will also cancel out m, just like in the above. M cancel out m. So we have V2 to be equal to, are you seeing this? 4 divided by 2 is 2. So 2 sine 53. I think I need to make this thing bolder. 2 sine 53 divided by sine theta. You can call this equation 2. See the two equations we have. Equation 1, V2 is what?
This is
5 minus 4 cos 53 over cos theta. Equation 2, V2 is what? 2 sine 53 over sine theta. Both of them are V2. So you just equate V2 in equation 1 to V2 in equation 2 and solve. Let me add this. So V2 in equation 1 is 5 minus 4 cos 53. 5 minus 4 cos 53 over cos theta V2 in equation 2 is, let me see it better, it's hidden here. V2 in equation 2 is 2 sine 53 over sine theta, 2 sine 53 over sine theta, 2 sine 53 over sine theta, 2 sine 53 over sine theta. I'm just equating equation 1 to equation 2. Both of them are all V2. So this is V2 and this is V2. So they are all equal. So we just solve. Can we do this? 5 minus 4 cos 53 over cos theta equal to this. Do you know we can take this up? Watch me. You can take this to this side, right? And take this one down. I can switch this. That can also happen in an equation. This can come up here and this can come down here. Yes, it's logical. Watch me. If you have this, A over B is equal to C over D. Cross multiply, what do you have? AD is equal to BC. AD equal to BC. Divide both sides by A. What will you have?
You have D equals to BC over A.
D equal to BC over A. Divide both sides by C. What will you have? D over C is equal to B over A. What did I just do? I switched this. Sorry, I switched this. This came up here. No, let me switch it. No, divide both sides by. Let me check it again. Or instead of wasting time, I can just say multiply both sides by sin theta. Maybe that will help you. Multiply both sides by sin theta.
Yeah.
So that it doesn't get complicated. Let me just multiply both sides by sin theta. Multiply both sides by sin theta. I will tell you why I'm doing that. Shall we?
Yes, sure.
Multiply both sides by sin theta. This will multiply by sin theta. This will multiply by sin theta. And we're going to have sin theta times that. Theta multiplied by 5 minus 5 minus 4 cos 53 over cos theta is equal to, of course, when you multiply both sides by sin theta, this sin theta will cancel out. Is it not? Okay, you still want me to write it? 2 sin 53 over sin theta multiplied by sin theta. I just multiply both sides by sin theta. This times sin theta and this sin theta. It's for a reason, because I want to obtain an equation of. Sorry? Tan theta is sin theta over cos theta. That's what I'm trying to achieve. When I multiply both sides by sin theta, I'm getting sin theta over cos theta on this side, which is tan theta. Why this one cancels out? This one will sin theta over cos theta will give you tan theta. See the original equation. I noticed that there's a sin theta down here. So I decided to multiply both sides by sin theta. So that this side will now be sin theta over cos theta. And then the sin theta here will cancel out. Have you figured that out? And what is sin theta over cos theta? Yeah, trigonometry ratio is tan theta. Sin theta over cos theta is tan theta. Sin theta over cos theta is equal to tan theta. So this whole part is tan theta. So simply we have tan theta, open a bracket, 5 minus 4. What is 5 minus cos 53 so that we don't waste time? Calculator quickly. 5 minus 4 cos 53, quickly. Quickly. 5 minus 4 cos theta. 4 cos 5 minus 4 cos 53. 5 minus 4 cos 53. 2.59. Are you sure?
Yes.
2.59. So this whole place is 2.59. So it's equal to, what is 2 sin 53?
2 sin 53.
Yes.
That's 1.59.
1.59. So can we just get theta? Can we quickly get theta? That means tan theta will be what? 1.59 over 2.59, right? So theta will tan inverse of that, right? 1.59 over 2.59. So help me to get theta. Theta is what? Tan theta is 1.59 over 2.59. So theta is tan inverse of that. What did you get? Get theta now. Theta is tan inverse of 1.59 over 2.59.
1.59 over 2.59.
Tan inverse.
31.5.
So theta is 31.5. We have gotten theta to be 31.5. degrees. We can just substitute in the previous question to get V2. Remember, we found V2 to be equation for V2. Any of this equation, V2 is 5 minus 4 cos 53 over cos theta. From equation 1. What I'm doing is just manipulation of components. From equation 1, V2 is equal to 5 minus 4 cos 53 over cos theta. Since we have found theta, let's just substitute. So V2 is equal to 5 minus 4 cos 53 divided by cos 31.5. Okay. 4 cos 53 divided by cos 31.5, just substituting theta that we got here. Can you simplify this? You already found 5 minus 4 cos 53 to be 2.59, right? If I'm not mistaken, that's what you got as 2.59, yes. So that would be 2.59 over cos 31.5. 2.59 over cos what? 31.5. Can you solve this quickly? Simplify this. 2.59 quickly. Cos 31.5 is equal to what? Pardon? 3.03. So V2 is 3.03. V2 is equal to, did you say 3.03?
Yes.
3.03 meter per second. All right. So the angle is 31.5. The velocity is 3.03 meter per second squared. This is basically what you do. Just resolve into components, vertical and horizontal. Apply the principle of momentum. Total before on the x-axis is equal to total after on the x-axis. Equate to get an equation. Do the same thing. Total before on the y-axis or vertical plane. Y-axis says 0 is only x-axis. Equal to total after on the y-axis. Remember, the one going up we have a positive. The one going down we have a negative. Get another equation. Just solve the simultaneous equation, whichever method you know. In this case, I got V2 equal to something in equation 1. I got V2 equal to another thing in equation 2. So I just equated both. Equation 1 equal to equation 2 is this equal to this. From there, we got theta and we got V2. That's basically it. Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to 2 main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.